In this video, we'll discuss powers of a matrix and how it relates to diagonalization. In this problem, we're given the matrix P and we're told that it diagonalizes the matrix A. We need to find a formula for the mth power of A. Well, to say that P diagonalizes the matrix A means that P inverse AP is equal to D, where D is a diagonal matrix. Now we'd like to isolate A in this formula. So to do that, I'm going to multiply on the left by P because that will cancel with the P inverse. I'm going to multiply on the right by P inverse, again, because that's going to cancel with the P. Now whatever I do to the left side, I have to do to the right side. So on the right side, we'll have PD P inverse. All right, P times P inverse is going to give us the identity matrix. So if we're being really careful here, on the left side what we've got is identity times A times identity. If we're willing to do a little bit of multiplication in our head, we'll realize that this left side here is really giving us the expression A, and so we figured out that A is equal to PD P inverse. Now to get the mth power of A, we're going to take A, which is PD P inverse, and we're going to multiply it by itself m times. So here's the first copy of A, here's the second copy of A, and we're just imagining this big product. Where we've written out A m times. Now what's going to happen is that we've got these products P inverse times P, P inverse times P, P inverse times P occurring at various points in this multiplication. And P inverse times P is equal to the identity matrix. So what's happening is that A to the m really simplifies to that leading P, and then D multiplied by itself m times, so D to the m times P inverse. And all these P inverse P's that we see occurring throughout this product here, those cancel out. To proceed with our calculation then, we're going to need to figure out what P inverse is, and we're going to need to figure out what D is. So let's continue those calculations over on the side here. Well, we were given the matrix P in the problem. We know how to find the inverse of a 2 by 2 matrix. So P inverse is going to be 1 over the determinant of P times the following matrix. We'll swap the diagonal entries, change the sign of the off diagonal. Now calculating the determinant of P, we've got 2 times 4 minus 7 times 1, that's 1. So our determinant here is 1. And P inverse really is just this matrix 4, negative 7, negative 1, 2. All right, so that part is done. Now we still need to figure out the matrix D. Remember we said right at the beginning of the problem that P inverse AP is equal to D. So let's say D is equal to, we'll copy out P inverse. We'll copy out our given matrix A. And we'll multiply by P, which was given in the problem. So let's keep our first factor on here, and we'll multiply these guys together. That's going to give us 16, negative 21, 8, negative 12. And then doing this last multiplication here, the matrix D is going to look like 8, 0, 0, negative 3. Certainly this should be a diagonal matrix. That is the point of this problem here. If you didn't get a diagonal matrix, then that would be a sign that there was some sort of algebra mistake made at some point in this calculation. Just recopied all the details from our previous screen. We found our formula for a to the m. Looks like p d to the m times p inverse. And we calculated p inverse and d as well on our previous screen. So let's put everything together now. Find our formula for a to the m. A to the m will look like our matrix P times the mth power of D, which is 8, 0, 0, negative 3, that's a diagonal matrix, times P inverse. First thing to notice here is that when we take a power of a diagonal matrix, the entries on the diagonal are just going to be raised to that power. So d to the m is going to simplify to 8 to the m, 0, 0, negative 3 to the m. Super important to have brackets here around that negative 3 to make sure that we're not getting any sign errors here. So let's recopy our expression. Here we've got p times d to the m times p inverse. Okay, now a couple more steps to complete our calculation. Let's keep our matrix P on here and we'll multiply these two matrices together. So we'll have 4 times 8 to the m and then negative 7 times 8 to the m. In our bottom row we'll have negative 1 times negative 3 to the m and then 2 times negative 3 to the m. Okay, we'll do one more matrix multiplication to finish up. Multiplying the 2 with the 4 here, we've got 8 times 8 to the m minus 7 times negative 3 to the m. So this entire expression here is the entry in the top left corner of our matrix. Moving over to the top right entry, we've got minus 14 times 8 to the m plus 14 times negative 3 to the m. And then going down into the bottom row, we've got 4 times 8 to the m minus 4 times negative 3 to the m. And then finally in our bottom right position, we've got minus 7 times 8 to the m plus 8 times negative 3 to the m. Now that we've completed all the matrix multiplication, we can stop and we've produced a general formula for the nth power of A.